In this video, I want to show you how to set up a circuit and how to measure the voltage and current in a circuit. So this is equipment very similar to what you have. You have a set of batteries, whereas this is a DC power supply, so that's just a little bit different, but it serves the same function. And as you can see, I have it connected. It's set on 3.3 volts, and so when I connect everything up, my light is lit, my light bulb is lit, and as you can see, it just makes one continuous loop. And that's one of the fundamental properties of current, is for current to flow, it must have a complete loop through which to flow. Here we have a multimeter, and this one's a little bit different than the ones that I had you buy. This is a much more expensive model, which is why I had you buy the cheaper ones. And your model doesn't have these 4 slots. You only have 2. So in this model, we have to be very careful. We have to put our plugs into the correct slot based on what we want to measure. All right. So first things first, let's say that I wanted to measure the voltage coming out of my power supply here. And if I were to do that, all I would have to do is unhook my circuit here. And what I'm going to want to do is put the multimeter on the volt setting. Now you'll see that this V has the solid line with the dashed line under it. That stands for DC voltage. The V with the wavy line stands for AC voltage. The A with the wavy line stands for AC current or AC amperage. The A with the solid and dashed line is DC amperage. And then the omega symbol is ohms. Okay, so since my power supply is on 3.3 volts, these numbers along the setting tell you the maximum voltage that that setting can measure. So if I set it to the 2, then I can measure a maximum of 2 volts with that setting if I'm measuring really, really small voltages. But since I'm measuring 3.3, I want to set it on the 20 volt setting. And I'm going to put it on that setting, and then all I'm going to do is plug in the voltmeter leads into the power supply, and I'll get my actual reading. So it's set on 3.3 and I'm measuring 3.1. Very, very close. This tells me that my power supply is producing almost exactly the amount of voltage that it claims it's producing. Okay, so now, how can I use my multimeter to take measurements in the circuit, right? So essentially with a basic circuit like this, there are 2 fundamental things that we may want to measure, 3 if you want to include resistance, but I want to measure the voltage that the light bulb is experiencing, and I may want to measure the current that the light bulb is experiencing. So let's measure the voltage first. Now I'm going to leave it on this setting, and to measure the voltage, all I'm going to do is place my voltage leads across the leads of the light bulb here, all right? And what we should theoretically find is that all of the voltage that's being supplied by the power supply is getting used up by the battery. Remember that voltage is potential energy per unit charge. That means that the charges that are flowing through the circuit have potential energy, and that potential energy is getting used up across this light bulb. So we should see that this light bulb is using up all of that voltage, and we're measuring 3.27 volts across the light bulb, which is very, very close to the 3.31. And in fact, anytime you add a load, such as a light bulb or a microwave or whatever, to a power supply, then the internal resistance inside the power supply also kicks in, which is why the volt reading is maybe just a little bit smaller than the pure voltage that we measured earlier, because there's a little bit of internal resistance here once the current starts to flow. All right. So now that we've measured the voltage across the light bulb, how do we measure the current through the circuit? So let me unhook these, and this is the crucial point. Okay, this is the absolutely crucial point. This is where danger happens. Okay, to measure the current, you actually have to make your voltmeter part of the circuit, part of the loop. So what I'm going to do is I'm going to turn off my voltage just to make sure that nothing happens. And you'll notice that this was my voltage and resistance knob, whereas these are my current tabs. And this is for up to 10 amps, and this is for up to 200 milliamps. Now there should not be anywhere near 200 milliamps flowing through this circuit. So we can use this knob, and you'll hear that when I plug this in, it's beeping at me, and that's telling me that I don't have it on the right setting. I had it on voltage, and it is expecting current. So now I'm going to twist this down to the current tab, right? And I want to now make my ammeter part of the circuit. So I'm going to plug my ground lead into the negative terminal of my power supply. I'm going to connect the positive terminal to the other terminal of my light bulb, and now my ammeter is part of the circuit. Okay, and it is set for 20 milliamps. That's the setting I just have it on right now. We'll see if we need to adjust that. And when I turn the circuit on, you can see the light bulb lights up, and I have a 1 here indicating that that is not the correct setting. So I want to measure 200 milliamps, and indeed, okay, I am measuring 134.8. Okay, so I'm measuring 134.8 milliamps through this circuit, and my amperage, or my voltmeter rather, my ammeter is part of the loop. Okay, so the current is exiting the positive terminal, flowing through the light bulb into the positive lead, into my ammeter, and then out of my ammeter back into the power supply. So I have one complete loop here. The crucial point is that you want your ammeter to be part of the loop. Okay, if you accidentally are trying to measure current but set it up as you would to measure voltage, right? So now I have my light bulb lit again, and let's say that I accidentally set this on measuring current, and I put my leads across my system like this, right? What would happen in that case is that I would short out the bulb, because when you have your ammeter on the current setting, the internal resistance on your meter is very, very, very low. So because your resistance is very, very low, if you were to insert your ammeter as you would your voltmeter, then all of the current bypasses the light bulb and it goes through your ammeter, and it will blow your fuse. Okay, so you want to make sure that if you're measuring current, that your meter is part of the loop. If you want to measure voltage, then you are free to put your voltmeter leads across your light bulb like this, because when you have this on the voltmeter setting, the internal impedance or the internal resistance of your voltmeter is extremely high. So none of the current, or very, very little of the current, actually moves through the voltmeter. Almost all of the current still gets forced through the light bulb. So that is how you want to measure your voltage and your current. Okay, that should get you started.